So this is the complete bridge crane kit. Has over 800 pieces. It's got, starts out with a crane. See how that works? And a through truss bridge. See that? And then it's got 3 cable stayed bridge sections. I call them sections because usually a cable stayed bridge has 2 towers. There'll be some photos on the website so you'll know what a cable stayed bridge looks like. But if you're trying to teach your kids about force vectors and applied trigonometry, all you need is one tower. So the cable holding up the deck, this is 3/32 steel, breaking strength of 600 pounds. So it's not going to break, it's not going to stretch. This will. I started out with 1/4-inch manila rope, untwisted it, kept untwisting it until I ended up with fibers. You got a good shot of that? And obviously these are going to break at a certain point. So there'll be a bunch of exercises where you'll have to determine how much load you're using. I usually use bricks. They're about $1 at Home Depot. They weigh 4.7 pounds. So you can have a whole bunch of bricks here, or you can have a bunch of them at the end of the deck. First you have to determine what the tension is, and you determine that with trigonometry. This is, let's say, 35 degrees. You can change it to a different angle. Come take a shot of this. So the cable holding up the deck can be at 2 different levels, 2 different angles, and that'll determine what the tension on the cable is. And what else do we have here? Oh, these 2 cross diagonal lines. If you didn't have them, the tower would wiggle. So something as simple as putting in these 2 lines, I use a trucker's hitch to tension them. Gives the tower much more rigidity. So we got 3 cable stayed bridges and 1 crane, which should be enough to keep a class of 20, 30 kids busy. For each cable stayed bridge, you'll need probably 4 kids. 2 kids to keep track of, to put the load on and to make sure these diagonal lines are tensioned so they're nice and taut. Then 1 kid to record all the measurements, how much load there is, where's the load position, what's the angle of the cable, and then one kid would be the foreman to be in charge of everything. And now with the crane, you've got a lot more formulas to play around with. I'd actually go with statics. I think statics is 2nd year engineering school, but I've been teaching it to 7th graders, so how hard could it be? So you'd have to compute how far away the load is from the pivot point. And the pivot point is where everything pivots. You see, the whole crane would want to rotate. So I introduced the concept of torque and applied trigonometry. That's it.